Hi, it's Kevin Bates here, and today another video in the Chess on a Blockchain series. And today I thought I would delve a bit deeper into the concept of consensus systems and blockchain protocols, because Ari made some comments on previous videos where we had a bit of a discussion about that, and I thought it was worth unpicking some of the stuff that came out of there. So Ari pointed me to an article where, quite rightly, somebody was showing how you could record a chess game on the Bitcoin blockchain, because you have this op return code where you can put a marker in the transactions to say it serves an extra purpose, which is very, very handy. You get about 40 bytes. I wish it was a bit more than 40 bytes, quite honest. And the issue that I had with that is that that's all very well if the players of the chess game are using the same chess client, which has a library that has been proved to only allow valid moves within the chess game. But the problem, of course, is that the Bitcoin database or set of blocks doesn't validate transactions in terms of chess. It validates them in terms of, do you have the right inputs in order to provide the output of a transaction that you want to, and have you signed it correctly, stuff like that. So it's focused on ensuring that the cryptocurrency transactions are valid. Now, if you're hiding chess moves within that transaction, Bitcoin doesn't care about it, and as a result you can go in and quite easily handcraft a chess move that is totally illegal. You could open by jumping your queen over your pawn all the way across the board and taking a pawn on the other side, and Bitcoin would just happily record that, provided you supply the transaction with a suitable number of satoshis to make it a valid transaction. So the idea of this chess on a blockchain idea is that you actually bake the chess rules into the blockchain protocol, and that would mean that if you try to submit an illegal move, say castling after you've moved your king, the blockchain itself would reject that as an invalid transaction, in the same way that the Bitcoin infrastructure rejects an invalid transaction if it's not been signed properly. So this is the difference between an external validator and an internal validator within blockchain. And if you're designing a new blockchain system with its own new consensus system, it's these kind of things that you really have to think about quite carefully, because if you make a mistake early on, it's going to be very hard, if not impossible, to rectify. And that would be one of the problems in launching a blockchain-based chess game, namely that you need to be absolutely sure that the chess engine that you bake into every single blockchain node hasn't got any bugs in it, because otherwise you're going to have to convince everybody to upgrade their nodes. What happens to old transactions that are invalid in the early parts of the blockchain, all of these kind of problems. And we've actually seen these problems in the Bitcoin world, that there have been a number of hiccups and forks in the past due to errors in implementation. So blockchain is not just complicated, it's very, very complicated. I, for one, would not have wanted to have been in the position of Gavin Andresen as the lead developer of the Bitcoin infrastructure, because I don't think I would have been able to sleep at night. Anyway, there's another video in the Chess on the Blockchain sequence explaining consensus systems a bit more. Hope you found it interesting, and see you in the next video soon. Bye for now.